All right, guys, it is Monday morning. We just finished up a training session yesterday with the guys from Willard Laser in Willard, Missouri, which is pretty close to Springfield. And then earlier in the week, we had the guys from JamWorks Robotics up in Pennsylvania down, and we did training for them on this laser that we'll be shipping out to them here in the coming weeks. So I didn't get a lot of footage on the laser training with those guys, but here's a picture that I snapped while they were here. But I did get a little bit of footage on this press brake and the training with it. And, you know, the press brakes are kind of my main focus now, so I always see a lot more content on that. So I wanted to just, you know, show you some of the footage from the training, and then also maybe answer some questions that a lot of people have about press brakes and why, you know, what are the different axes and why would you need one, you know, and that kind of thing. So this is a very nice, but also very expensive solution, but also very capable. So it's kind of a get what you pay for kind of thing. So it's a 10-foot, 220-ton gantry style machine. Gantry style meaning that we don't have any C-frames interrupting the flow of the sheet. So you have full 10 feet access at full depth, versus on a C-frame machine, you can see the C-frame notches back in there. And so you don't get full depth, full width access. You're kind of limited to that on full width. All right. It's also an 8+1 axis machine. And I want to show you a little bit about that, you know, the way the back gauges are and why you would need that, you know, where that comes into play and why you would need it. This machine also has a $15,000 option here for hydraulic tool clamping. And if you notice, you know, like your normal press brakes are going to have tool holders like this, or they may have the quick change style that you don't need any tools to open up like these have. So you can reposition your tooling just by unclamping that, you know, pulling things out, putting things in, but you're limited to only placing your tooling where the tool holders are, or you're kind of forced to move the tool holders or take some out, or, you know, those kind of things. So this solution here with the hydraulic tool clamping is pretty slick. So you have continuous clamping across the full width, so you can basically place tools anywhere. And so if we grab just a little punch segment here, kind of show you how it works. So what I'm going to do is unclamp it here with the hydraulic release. So that's released the tooling, and now it's just in there loose, right? You can slide it anywhere in there, create, you know, gap spaces for the jobs that you're trying to do. And then to get new tooling in, let's say we needed a punch segment over here, just pop it up into place. You can press that button and release it, or you can, you know, drag it out and slide it out the end if you want to. So, you know, you just space everything out, get it where you want it, and then re-enable the clamping here. And now we're rigid, firm, ready to bend. So it's a very nice option. But like I said, you know, 8-axis, gantry, 3D controller, every one of these, you're talking about like, boom, 10 grand, 15 grand, 20 grand options. You know, it goes from, in a hurry, it goes from, you know, a 10-foot brake, 4+1 axis at 86,000 up to 135,000 for the same tonnage and width of machine by adding these features. But sometimes, depending on the parts that you're making, it's super handy and nice to have. All right. I wanted to show you where the 8-axis really comes into play. I've got a video clip of a part we made during the training, and let's take a look at that now. So you're looking at Tim from Willard Laser, and we also have Darren down as well, and one of their other guys. They actually flew down in their own little small private airplane to my local airport, and then Tim drove down with a camper. But anyway, this is a part that really demonstrates the 8+1 axis and why you need it. So let's take a look and see what happens here. So that first series of bends there, any brake could do that. We're just, bending a square part butted up against the back gauge. But now you can see X1 and X2 axis are offset from each other. And that's because of this odd shaped flange, tapered edge. Your normal brake, you're going to have to kind of rig something up to be able to do that. Versus on this, you just import the drawing, get the part butted up, and then make the bend. Now on this part, I think we had to do a little bit of correction and fine tuning to get this working right. But after a little bit of trial and error, we got it, and we're getting our critical dimensions pretty spot on with some fine tuning on correction. And then now we're flipping it the other way, and you see the back gauge fingers did the opposite. One came in, the other one went back. And I got some other clips here in a second that show it a little bit better. So there's a couple things going on here. If you'll notice, we need clearance on the die for the flange that we just bent to clear as the next flange is being bent. And then again, you have the X1 and X2 offset from each other to catch the tapered edge. So, squared up brackets, hey, those are easy. Fabricator brakes can make those. That's why I call it fabricator brake. But when you get into more complex forming where you have all these, different flanges, different edges, lots of tapers, you need a more, sophisticated brake. And then one with a 3D controller where you can just import the drawing and get very close right out of the gate, and then just do a little fine tuning. And again, you see now we're going to move and flip this part around so that the clearance is on the other side, and then the X1, X2 taper is also flipped the other way. All right, so you saw that, and again, we're in the Ramsey Custom Shop down in Texas, and my name is Gary, by the way, for those that may be new to the channel or whatever. But anyway, you can scroll back on my channel and find some older videos of me going on site to a lot of laser and press brake installs, and we've just grown to the point where we can't really do that anymore. So we host a lot of training sessions here in the shop in Texas. If you want to buy a brake, you're more than welcome to come and get training. The Fabricator and the 2D Precision Series, we typically just ship those out and do training remotely via video chat or just on the phone. And but the 3D brakes, they're a little bit more complicated, and it's worth it to come get a day's worth of training, about 6 hours or so, and I can have pretty much anybody with some decent skills running this machine and understanding how to, control it and get your parts to come out accurate. So anyway, here's one that we made during the training, and these guys have a lot of stainless parts that they've got a chance to make for a company in their area, and they got about 10, 15, 20 drawings already. And so a part like this seems kind of innocent, but it really has some critical dimensions. One of them being the spacing of these two holes obviously are going to get bolted to something else. So how far these are apart, and those can't be at the right widths unless this angle and this angle is correct. Because if these two bends or these four bends right here are 1 degree off from each other, you could get a part that would sit flat like that. You can see that's sitting, well, this one actually rocking, but we'll bend another one here in a minute and show you how to get it flat. But anyway, so this angle should be 120 and this one should be 120. If this is 119 and that's 119, these holes right here are going to be closer together, and this is going to stand taller, so your part's not going to fit. All right, so now here's an interesting thing. My buddy Eric on Instagram is at Genuine Metalworks over there. Has a pretty neat product. Some of you guys already know about it. Some of you guys have them. And we're going to be getting some soon that are branded with, that are going to be the only ones made in red, hopefully. And they'll be branded with the Benforce logo, which is, you know, our brand name right there for these brakes. And so where it comes into play is, let's take a look. We'll bend one of these up right here. And show you how this works. So here's a blank one. So the guys at Willard Laser, they brought down, they cut out several blanks, you know, just some test pieces. And they brought the drawings for it so that we have a blank that was cut from a 2D DXF on their laser. And then they brought their 3D file. And let's just open it for this. All right, so we're gonna go here, and no, we're gonna go open the drawing. So here's that part right here in 3D. So we're gonna do that and go load program, bring that in. And I believe this one, hopefully we saved it. No, we didn't. So it needed some corrections to make it accurate here and here. And I think it was about 2 degrees, honestly. And then I think we had a little bit of correction on the back gauge, maybe 10 or 20 thou. I'm just going to go 0.015. And so we'll do that. And then we'll go to, let's see, we're ready to run it. We'll go here to graphic mode so we can run it in 3D and see what's happening. So there's our part. So you see where this creates a problem, right? Well, let's go ahead and hit start and we'll bring it up there. So you have a tapered corner and you don't have any way to square that up against the backstop. But thanks to the guys at Genuine Metalworks, we do have, look at this squaring arm right here. So all you're really doing on the back gauge is using it to set the depth. The squaring part of it is done by this magnetic squaring arm. And these can be, you know, they're sold in pairs or just one. And you can have one on the front and one on the back, because you'll see in a second we need that. So let's go ahead and bend this part up. Oh, actually, let's see. I might have the wrong tooling in there. Let's see what tooling this was set up for. Okay, no, that's right. So it's got our 12 millimeter or 1/2 inch V opening, and that's what we have it in there for. So let's go back to here and graphic and just bend this part up and show you this. And super critical to, on a part like this, to hold the dimension here butted and then hold the square over here, and also keep your fingers clear so you know, so you don't get in trouble there. So let's whoops, didn't hit start. All right, and so now you can see what that's asking us to do right there. So we're gonna hook this down and then back against the back gauge fingers in there. Get that. All right. All right, now you see the configuration it's showing next. Gonna be this. This is where you need the other one on the inside, but I think we can possibly manage it if we're super careful. So we only have a little bit to square off of right here. That's where you would put another one on the inside here. All right. So now we don't even need to have our fingers in there. We can just let the whole thing rest. Okay. And now we have this last flange, and the orientation is like this. Whoops. Oh yeah, this one for sure, you got to have it on the back side. So let me Let me flip that around real quick. I was thinking I remembered that from yesterday. And this, it doesn't even really matter which way you catch it, as long as it's just above the. So that'll work. And I can tell that we don't quite have our corrections fine-tuned there. By the way, that part, there should be a little bit of clearance right there, but anyway, that's the whole point I'm trying to demonstrate here, is the squaring. So now let's finish this bend up. There's the part. Let's see. So you can see this one's sitting pretty square. No teetering. And then so I've kind of set up this inspection station, and if you're serious about making accurate formed parts, that you do something similar. And this is just a height gauge. You can get it off Amazon, and and this is a granite block if you want to get real precise, but otherwise you can just use it off of any flat surface and get a good number. But this lets you actually measure certain heights and flanges and things, and then fine-tune your correction to dial in that part so that it's perfect to measure either way, maybe, hopefully. Here's another common part. They brought the flat DXF file, which we're cutting on the laser in the shop, just one part out of a little drop here. And then they also have the 3D step file from Autodesk Inventor, which is the rich man's version of Fusion 360. And so we'll take that over to the brake, import the drawing, and bend this part that we're cutting on the laser. So 2D DXF flat for cutting, and then that same part as a 3D step file exported separately and imported into the brake.
Get inside for the money shot.
Okay, here's another part that they cut the blanks on and brought with them, and then brought the step files with them, and we imported it. By the way, this is the Metalix MBend 3D workspace software that does come with the machine to help you do simulations and figure out what tooling, bend sequence, all that kind of stuff. So it'll actually simulate the bend. So if we zoom in here a little bit, we can see this. Let me go in further. You can kind of see that now. Let's go in just a little bit further. So now we can simulate the bend here. We'll just hit play. Okay. Now you can go single play mode, and we will go back to the first step. And if you notice right here, we have two flanges that are at the same height, but they're not on the same bend line. So that creates a little trickiness in this, and let me show you that. So here we go. We're gonna go in single step mode here. We're just gonna do one flange at a time. So you can't really see it in this view, but over here, let me zoom out a little bit. There's some navigation where we can rotate the brake around, where we can actually see what's going on inside of there. So let's see, yeah, let's go down this way and then go back this way. Now you can kind of see back inside of there. So what it does is, on this second bend, the back gauge finger on the right side is pushed further back. And so we'll go ahead and bend it again so that it can bend that middle flange. And then now we have an oddball flange on an angle, off the corner, and we'll bend that one. And then here, let's show this part in action while we were in the training.
Over.
Big thanks to the guys from JamWorks, like I said, for coming down for the laser training. And then also Darren and Tim from Willard Laser in Missouri coming in to get training on their brand new brake that we'll be shipping out to them this week.